Hey, very good morning, all my dear future doctors. So, how is everyone? Welcome back again to your Unacademy NEET English channel. My dear students, do let me know that am I audible and visible to all of you or not? So, today, we are going to start with tautomerism. But before I start, everyone do let me know that can you hear me and see me? That is perfectly. Am I audible and visible to each and everyone? I want to see green signal from the chat section. So, really, it's very good morning once again. So, I'm your HSP Baba, Magical Chemistry Group. I don't think any introduction is required. So those who are regular students, they know very well that HSP Baba, yes, dual master's degree, 2004 MTech and 1999 MSc gold medalist. So, okay, my dear students, now today we are going to start with fabulous topic that is tautomerism. It holds a hell lot of weightage. But before I start, let me tell you the most important thing that tautomerism requires the knowledge of resonance, and that's why this is the part of structural isomerism. But then also I haven't taught it over there in the structural isomerism, because just to understand tautomerism we should have to have knowledge of GOC, that is resonance, inductive effect, hyperconjugation. So I hope that everyone, you must have seen resonance. If you don't know resonance, then you won't be able to understand tautomerism. Mark my words. So this lecture is mainly for those students, those who are having basic knowledge of resonance. At least you should have to have basic knowledge of resonance, then only you are going to understand this chapter. Now kids, those who are new to this channel, subscribe it, and those who are regular students, kids, see, too much sweat is there, even though the AC is switched on, but then also you see that is the dedication required, kids. Now all my dear kids, hit the like buttons. I want to see, sir, optical isomerism is finished. No, Apuji, oh my god, I was unable to see this chat section. Kids, optical isomerism, I thought that it should get completed in one lecture only. You know that I took 6 hour duration, one lecture based on optical isomerism, but few part of that optical isomerism is being left. Don't worry, I will try to take one more lecture, and definitely I will take one more lecture of optical isomerism, but that in the coming week, the next week. Okay, now let's start tautomerism. Any other queries, kids? Any other doubts? Do let me know. Any other doubts? Tautomerism. Now, tautomerism word is not giving an idea about actually what it is. So, remember one thing, that tautomerism means some atom is moving. Some atom is moving, and you know that which atom is most mobile. Write down in the chat section. I want to see. Oh, AK Bala Mas, thank you, kids. Your words, your appreciating words means a lot. And your presence is the best present I could ever. Now, This tautomerism word means, just keep in your mind that tautomerism word means any atom is moving, any atom is in moving condition, any atom, and that atom, you know that till now the scientists, they are unable to find out that atom is how much mobile it is. That is being your hydrogen atom. Sometimes people say it behaves like alkali metal, and some other time it behaves like halogen. Any atom that is hydrogen moves. Now, when this hydrogen atom is moving, definitely along with the atom is like human being, like we human being. And if we are moving, money is involved. No human being is moving without the involvement of energy. Energy can be in any form. Money is also one form of energy in chemistry. I mean, money is electron. That means electron is also moving. Electron must be moving. Must be moving. That means atom and electron is moving. And by their movement, they are going to produce another compound, and both the two form of compound will remain in equilibrium. That means when the atom is moving, then it is going to form another atom, and these two compounds will remain in equilibrium, and that's why tautomerism is also known as dynamic equilibrium. Also known as this tautomerism is also known as dynamic equilibrium. Dynamic equilibrium. Now, I said atom and electron is moving. That means the bond is moving. Bond as well as atom is moving. Bond as well as atom. Bond along with atom moves. Bond along with atom moves. And that's why this is known as desmotropism. Another name is desmotropism. What is another name, kids? Desmotropism. 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 So these are the names. How many names? I said it is known as tautomerism. It is known as dynamic equilibrium. It is known as desmotropism, and it is known as tautomerism. These are the names by which this compound is known as. AK Bala Mas, yes, you can join anything. Now just focus over here. Now question arises, this hydrogen atom is moving from one atom to another atom. What should be the position of that atom? So let me tell you, kids, this tautomerism is of three types. Tautomerism is of three types. Tautomerism is of three types. Now, three types. What are these three types? Let me tell you. 1, 2, 3. These are the three types. Sir, what are you doing? Write down something at least. Okay. Now, hydrogen atom can move from one atom, let us suppose A to B. This hydrogen, let us suppose this hydrogen atom is attached with A, it can move to V. So, from one atom to two atoms. This is known as Diade system. Which system? Diade system. Now, hydrogen atom can move from A, B, C. The hydrogen atom is attached with A, that means 1, 2, 3. From 1 to 3, it can move. Triad system. Triad system. Now, your hydrogen atom can move from A, B, C, D, E. Oh my God. 1, 2, 3, 4, 5. The hydrogen atom is located on this, and this can go to fifth atom, pentad system. Pentad system. Now kids, 1, 2, 3. 1, 2, 3. Which is most important? I will tell you, this is being triad system is very, very important. So 99% questions will be based on this system only. So these two are very less important. This and this is very less important. But yes, I will give you example of this system also. But this we will see in detail. Which system we are going to study in detail? This we will study in detail. Will study in detail. Okay, kids, ready? Are you ready, everyone? How's the Josh? Do let me know in the chat section that yes, we are ready, kids. Tetrad not possible. It is odd number. 1 to 2, diad, triad, pentad, not tetrad. Now, I will let you know what is the mechanism why tetrad is not possible. I will let you know. Show me the Josh in the chat section. I want to see some fire. I want to see some fire, kids. Yes. Now see. There is only one example of diad system. Only one example of diad system. So if I talk about diad system, only one example in our syllabus. What is that? What is that example? Hydrogen cyanide, HCN. You can see hydrogen cyanide. This hydrogen is attached to this carbon. Now, from carbon, it will move towards nitrogen. Now, the compound will be N double bond, coordinate bond, C. You can see the hydrogen atom was attached on first carbon, that was carbon. Now, from carbon, it has gone to nitrogen. So, if anyone is asking what is the relation in between hydrogen cyanide and hydrogen isocyanide, this compound can also be written as hydrogen isocyanide, and this is hydrogen cyanide. What is the relationship in between these two compounds, kids? So, definitely these two are, yes, these two are tautomers. These two are tautomers. Now, kids, you will say this is cyanide, that is isocyanide, sir. As we know that this is being cyanide and that is being isocyanide. And when we were studying structural isomerism, you said, sir, these are functional isomers, cyanide and isocyanide being functional isomers. So tautomers and functional isomers. But kids, these two are both. They are your functional isomers as well as tautomers, but preference should be given. See, preference. We know that RT, FM, CP. This was the preference order. Do you remember? Kids, do let me know. Do you remember? So, who is more preferable? This tautomer or functional isomer? Who is going to get more preference? So, tautomer is going to more preferred as compared to functional isomer. Is it clear? Wow. Write your famous position. That was the trick. Write your famous position. Everyone is able to understand, kids? Now, this is the only one example of diad system. Now, the rest of all the examples are on tetrad. No, tetrad is not possible. Triad system. So, let's see. Triad system is in detail. We are going to see to it in detail. But let me give you the trick. Just see the trick by chance, if nothing is striking to your brain, then remember the trick that will help you, because this trick is going to hold a hell lot of weightage. See everyone, I'm going to tell you about triad system. Triad system. X double bond, Y single bond, Z, and if atom hydrogen is attached to Z and this atom is acidic, if this is acidic hydrogen, so I will say this is first carbon, this is being second carbon, and this is being third carbon. This hydrogen will move from, do remember what I am telling you, this hydrogen will move from 1 to third atom, and this double bond will move in between 1 and 2. All the questions you can do with simple trick. This is the best awesome trick. Awesome trick, best trick, whatever you want to say, you can say this is the best trick. Now, later on, I will tell you number of examples, number of things, but do remember these three are non-metals. X, Y, Z are non-metals. X, Y, and Z are non-metals. X, Y, and Z are non-metals. Non-metals. This hydrogen atom will go to third atom and this double bond will come in between 1 and 2. How it would look like? See everyone. It will be like this: X, Y, Z, and you can understand without mechanism, I am telling you, without mechanism, this trick I am telling you, this hydrogen atom will come to this X. Now you can see this was 1, 2, 3. Now hydrogen atom is on third atom and double bond is in between 1 and 2. So these two compounds are holding a relation. What's the relation? That these two compounds are tautomers. These two compounds are tautomers. Tautomer of each other. Tautomer. Tautomers. Now, are you ready? Let's see the examples so that we can understand. Now see everyone. How will you come to know this hydrogen is acidic hydrogen or not? You can also say this is your alpha hydrogen. Alpha hydrogen. Now let me tell you how to find out alpha hydrogen. Calculation of alpha hydrogen atom. See everyone. Calculation of alpha hydrogen atoms. Calculation of acidic alpha hydrogen atoms. See everyone, if I say this is one compound, CH3, C double bond O, H. Either to you can compare it with X double bond Y, Z. This is sp3 hybridized carbon and this is the functional group. This is your carbonyl group is, this carbonyl group is functional group. Functional group. Now, this carbonyl group is functional group. Whatever the atom, this atom is directly attached with this carbonyl group. This is known as alpha carbon and these are known as alpha hydrogen atoms. Gets. So this compound is having how many alpha hydrogen atoms? Do let me know. This compound is having, how you find the sp3 hybridized? AK Balaji. See, this carbon is having how many sigma bonds? This carbon is having 1 sigma bond and 3 sigma bond. Let me write down. Let me write down. See, this carbon is like this. Carbon, hydrogen, 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 C double bond O. Now see, gets This carbon is having how many sigma bonds? 1 sigma, 2 sigma, 3 sigma. So steric number of this carbon is 3. 3 means sp2 hybridized. 1s and 2. 1 plus 2, that is coming out 3. Now, if I say this carbon, see 1, 2, 3, 4 sigma bonds. So the steric number is 4. 4 means sp3. AK Balaji, is it clear? AK Balaji, you got it? Everyone, you got it? Got it. Priyanka ji, you got it. So this compound is having 3 acidic alpha hydrogen atoms. Now, if I say I'm provided with this compound, just find out this acetone is having how many acidic alpha hydrogen atoms. Do let me know, everyone, in the chat section. I want to see, this is your carbonyl group. You can say X, double bond Y, Z. This side hydrogen X, double bond Y, Z. This side. So 3 alpha hydrogen atoms. 3 alpha hydrogen atoms. So total 6 alpha hydrogen atoms. This is having 6 alpha hydrogen atoms. Got it? Very good. Now another question. See, everyone try to find out. I'm writing the compound over here. I'm writing the compound at this place. Compound acidic alpha hydrogen atoms number. Acidic alpha hydrogen atoms number. So the compound, first compound, I want to see the answer in the chat section. Fast, kids, fast. H, C, double bond O, H. This compound is known as formaldehyde. Formaldehyde. So how many alpha hydrogens? I want to see number of alpha hydrogens in the chat section. Fast, fast, kids, fast, speed. The first compound. The second compound is CH3, CH2, CH double bond O, propanol. Propanol. Everyone, I want to see your answer. No alpha hydrogens. 0. Very good. 0. The second compound. Second compound, kids. Second compound, 1, 2. Kids, it is having 2 alpha hydrogen atoms. See, this is carbonyl group. So this is 2 alpha hydrogen atoms. Third compound. Third compound. You see 2 over here. 2 over here. This is having 4 alpha hydrogen atoms. 4 alpha hydrogen atoms. Now see, I'm going to write another compound. Another compound. Do let me know how many alpha hydrogen atoms. This is your compound, benzaldehyde. Benzaldehyde. Do let me know this benzaldehyde is having how many alpha hydrogen atoms. Benzaldehyde. Benzaldehyde is having how many alpha hydrogen atoms? This was having 4. Yes, benzaldehyde is having how many alpha hydrogen atoms? So I want to see your answer. Kids, everyone, do let me know what's the answer. Benzaldehyde is having how many alpha hydrogen atoms? Yes. Yes, everyone. Hey, what are you doing? Just to let me know how many alpha hydrogen atoms. 1. Omar is saying 1. Arti is saying 0. Princia is saying 0, 1. Some are saying 1, some are saying 0. See, this is your carbon. How much valency? 1, 2, 3, 4. The valency of carbon is 4. So this carbon is having no alpha hydrogen atom, and that's why this question is very, very important. No alpha hydrogen atoms. No alpha hydrogen atoms. So this benzaldehyde cannot show tautomerism. Can't undergo tautomerism. Are you able to understand? Can't undergo tautomerism. Is everyone able to understand? This compound cannot show tautomerism. Next compound I am going to give you. Do let me know. The compound is, see everyone, this is your compound. Do let me know how many alpha hydrogen atoms this compound is having. Acidic alpha hydrogen atoms. Acidic alpha hydrogen atoms number. Do let me know. What's your answer? Formaldehyde, why 0? See, some kids are asking why formaldehyde is having 0. See, this is your compound carbonyl group. This is your carbonyl group. Now there is no alpha carbon, no adjacent carbon, no adjacent carbon, no adjacent carbon. So no alpha carbon, no adjacent carbon, that means no alpha carbon, and no alpha carbon means no alpha hydrogen atom, right? Now this compound is having how many? 3. Yeah, that is the most important thing. See kids, here you have to remember, see everyone, this is your carbonyl group. This is your carbonyl group. Now this is alpha carbon, this is alpha carbon. But kids, see, this hydrogen is attached to sp2 hybridized carbon. Whenever C double bond C is there, double bonded carbon are being sp2, sp2. They are not sp3. So this hydrogen is not acidic. It is alpha hydrogen atom. It is alpha hydrogen atom, but not acidic. Why not acidic? But not acidic, because this carbon is sp2 hybridized. This carbon is being sp3 hybridized. So its hydrogens are acidic alpha hydrogen atoms. So this compound is having just 2 acidic alpha hydrogen atoms. 2 acidic alpha hydrogen atoms. Kids, are you able to understand? Got it or not? Have you got it? Do let me know. This question is really very, very important. This hydrogen is not acidic because it is attached with double bonded carbon. Got it? Now, let me give you another question. See to it. Everyone see to it. If I say this is your compound, now this compound is having how many acidic alpha hydrogen atoms? Do let me know. This compound is having how many acidic alpha hydrogen atoms? Number of acidic alpha hydrogen atoms. Everyone do let me know. Number of acidic. Princia is saying 4. Omar is saying 0. Vidhajanani is saying 0. Now kids see. Everyone see to it. This compound is actually like this. This compound is actually like this. C double bond O. This is carbon. This is having CH3. This is having CH3. This is having CH3. This is having CH3. Now everyone focus on, this is carbonyl group. This is being carbonyl group. So this is alpha carbon sp3 hybridized. This is also alpha carbon sp3 hybridized. But these carbons valency, you just check it out. This carbon's valency is how much? 1, 2, 3, 4. No hydrogen. 1, 2, 3, 4. No hydrogen. So answer is 0 acidic alpha hydrogen atoms. So cannot show tautomerism. Can't show tautomerism. Everyone got it? Is it clear to all of you? Is this question clear to all of you kids? Are you able to understand or not? Now see the awesome question I am going to give you. Everyone focus on the question. This is your question. If this question has been asked, how many acidic alpha hydrogen atoms How many acidic alpha hydrogen atoms? Will it show tautomerism or not? If it is having acidic alpha hydrogen atoms, it will show. Otherwise, it is not going to show tautomerism. Everyone, your time starts now. Do let me know, everyone. I'm waiting for your answer. Oh my God, you have become smart. You kids really have become smart. Now you are rocking. You are rocking, kids. With respect to this, with respect to this carbonyl group, 0, 0, no alpha hydrogen atom. But with respect to this, 4 acidic alpha hydrogen atoms. Now, kids, you are able to understand this compound will show tautomerism. This compound will show tautomerism. Now, I'm going to give you one question. Try to find out the answer of that question. Then I will let you know how tautomerism takes place. But right now, the question is, how many compounds, how many compounds will show tautomerism. Now, what is required for tautomerism? If they are having acidic alpha hydrogen atoms, they will show tautomerism. This is the criteria. Now, compounds, I'm going to draw compounds. Compound A is focus, just like you are going to give. NEET examination is right now going on. You have to do it like this. ET means ethyl. ET means ethyl. Now, these are total 5 compounds. What's your answer? How many compounds will show tautomerism? This is the question. So, what's your answer? Kids, how many compounds will show tautomerism? 1, 2, 3, 4, 5. Balaji is saying 4 compounds. So just treat it like your NEET examination. Option D. Omar Adnan is saying option D. The rest of others, only one, only one, only one. That is the correct answer, only one. This will not show because its hydrogens are being sp2 hybridized. So this compound will not show tautomerism. sp2. So it will not show tautomerism. Cross, it will not show. Benzaldehyde will not show because it is like this, and already I have told you that it is not having any alpha hydrogen atom. Formaldehyde will not show because it is also not having alpha hydrogen atoms. Now this is having 3 alpha hydrogen atoms, so this compound will undergo 3 acidic alpha hydrogen atoms because this is being sp3. So yes, this will show, and this is not having any alpha hydrogen atoms, so this will not show. So answer is only one. Kids, everyone is able to understand. Do let me know. Hey all, How many of you got the correct answer? Show me the thumbs up. Otherwise, thumbs down. If your answer gone wrong, thumbs down. Yes, if it is correct, thumbs up. Normal alpha hydrogen atom and acidic alpha hydrogen atom different. Let me tell you. Yeah. Yes. Now see, let me tell you. Everyone see to it. What's the difference? If I write down this compound CH3, CH2, C double bond OH, and another compound, if I write down like this CH2, double bond CH, C double bond OH. Now see, try to understand. The first carbon, this C double bond O is being carbonyl carbon. Any carbon attached directly, this side no carbon, this side no carbon, no carbon. This side, this is carbon, this is alpha carbon, right? Like this is carbonyl group, no carbon, that side, no carbon. But this side, this is the carbon, this is alpha carbon. Both are being alpha carbon, but their hydrogen atoms, they are alpha hydrogen atoms. These are two alpha hydrogen atoms. This is only one alpha hydrogen atom. But what we require for tautomerism, we require acidic alpha hydrogen atom. Acidic means attached to sp3 hybridized. Acidic alpha hydrogen means acidic alpha hydrogen atom means attached to sp3 hybridized carbon, adjacent to carbonyl group, adjacent to carbonyl group. Now see kids, this carbon is attached with 4 sigma bonds, so this is sp3 hybridized, so these are being acidic hydrogen atoms. But see, this is having just 2 sigma bonds, so this is being sp2 hybridized, so this is not acidic. So which compound will show tautomerism? The first compound will show tautomerism, and this compound can't show tautomerism. Everyone is able to understand. Now, is it clear to each and everyone? Kids, do let me know. Irshad Ganesh Singh, sir, I started now. Can I go for previous lecture or continue live? You can continue live. I will tell you each and everything. A little bit knowledge of resonance is required, and that I will keep on telling you kids, so everyone is going to understand it, right? Now see kids, how tautomerism takes place. Till now I have told you acidic alpha hydrogen atoms. Till now I have told you the trick, each and everything I have told you. Now I am going to tell you the mechanism of tautomerism. See, the mechanism of tautomerism. Everyone is ready for the mechanism of tautomerism, kids? Is everyone ready for the mechanism of tautomerism? Mechanism of tautomerism. Now try to understand the mechanism. Everyone. This is your compound CH3 CH double bond O. What is the name of compound? The compound's name is acetaldehyde. Acetaldehyde. This is the general name. Its IUPAC name is ethanol. Now kids, if I put some base, in front of it, like NaOH, Na positive, OH negative. You can understand this OH negative is base. This is being base. Now kids, what the base requires? Base requires acidic H just to do acid base neutralization reaction. So this base will say, oh, acidic H, I wanna you, I will take you, I will take you. Are you ready? I've seen you. I want to form a bond with you just to neutralize my charge. Please, please, please come in my life. So this carbon is saying, oh, you go, you go, you go. Why the carbon is talking like this? Just you go, you go, you go. Because once this proton is being lost, once the proton is being lost, this carbon will start dancing. This carbon will start dancing. Do you know why? This carbon will say, oh, I have got one negative charge. Now I will do resonance. Now I will do resonance. Now this carbon is happy. It has started dancing that I will do resonance. This electron will move on this side. Now this electron will go on that side. Earlier it was sigma bond. It was not able to show resonance. Now it is doing resonance. Resonance, stabilized, resonance, stabilized. Now whenever any compound is able to do resonance, that is the festival time. Whenever the carbon is having any charge adjacent to double bond, then that is going to be the festival, and they have started celebrating the festival. Oh, I'm doing resonance. So they have started doing resonance. Now see what is going to happen. Everyone see to it. This electron will go over there and this electron will go over there. Now how it will look like? See to it. It will look like this: CH2 double bond CHO negative. These two are resonating structures. These two are resonating. Let us say, if I say this compound's name is A and this compound's name is B, then A and B, what is the relationship in between A and B? A and B are resonating structures. Resonating structures. Now this proton, once the proton has been lost, it has formed water. It has become water. Water. And Na plus was moving like this in the solution. Now Na plus said, reaction is about to complete and I was the catalyst. Reaction is about to complete and I was the catalyst. Make me like as I was. I'm being the catalyst. I want to become like in my original condition. Now this Na plus will ask water, hey, return my OH negative. I want to take my OH negative back. I'm being the catalyst. Now this H plus will go where? Where this H plus will go? This H plus will say, oh my God, who is going to give me shelter? So this H plus is going ding 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 ding. Yes. Wherever the negative charge is there, this H plus will go to that atom, and once this H plus has gone to that atom, what is going to form? Kids, do let me know. Everyone do let me know what is going to get formed. This H plus is going to that oxygen negative. Ding ding ding, shakat. Now this compound will convert. This compound definitely will convert into this compound. Just see to it. Everyone see to it. Which compound it is going to get converted. CH2 double bond CHOH. This is the compound. You see, this is the compound. This hydrogen atom has moved from 1 to 3. From 1 to 3, and double bond got shifted in between 1 and 2. So these two, let us suppose if I say this is X and this is Y, what is the relationship in between X and Y? X and Y are being tautomers. X and Y are tautomers, they are being tautomers. Kids, are you able to understand? Everyone, you liked it? Have you liked the sound, the ting 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 sound, what they were talking about, what they were having, the language, what there was celebration? Do you like that celebration? Now see, kids, everyone is able to understand. Do let me know. Oh my God, Bala, that's fantastic. Now see, Bala, everyone, if this is your compound, CH3, C double bond O, CH3, the same mechanism is going to happen. This is your keto form. This is your keto form. Ketone, it is ketone, keto form. Now, once it is going to do tautomerism, what is this going to happen? This is first, this is second, this is third. Hydrogen atom will go from 1 to 3 and this double bond will come over here. Now you will get its tautomeric form. What is that tautomeric form? You will get CH3 COH double bond CH2. Now see, kids, this double bond means in. For double bond, word will come in. This is being in, and you know this is OH, alcohol. For this part, this is being OH. It will come all. So combine it in all, enol. This is being enol form. These two are tautomers. This is known as keto form, that is known as enol form. Everyone, I hope everyone is able to understand. This is being keto form, that is being enol form. Keto, enol. So keto enol tautomerism. This type of isomerism is known as keto enol tautomerism. Keto enol tautomerism. Keto enol tautomerism, kids. Now, this is actually the sign of resonance. Let me delete it, or I can make it like this. That is more appropriate. This form, let me remove it. And let me put which is being more stable. This will go like this, and in the backward direction, it will come more. So which form is being more stable? Can you see with the help of this equilibrium, which side it is going more? The right hand side or the left hand side? Left hand side. Do remember one thing, the examiner is going to ask which form is more stable. 99% keto form and only 1%, even less than 1%, enol form. So this dynamic equilibrium remains on both the side, but this is being more stable form. More stable form. Keto form is more stable form. Thermodynamically, this is more stable. Thermodynamically, this is being more stable form. The difference between keto and enol form is favoring the equilibrium more towards keto form by 12 kilocalorie per mole. This is the difference in the energy level of keto and enol, but examiner is not going to ask what amount of difference is there. Just do remember, keto form is more stable than enol form. This is experimentally determined. Now, kids, question arises, what is experimentally determined? That keto form is more stable. That keto form is generally more stable. Generally, this generally word is very dangerous. Generally more stable. Why? Kids, this generally word is very dangerous word. Ask me why. Generally word says that not always. There are some compounds where enol form is more stable, and that is the question. Shiv Kumar is saying, sir, we like the session itself, then we also like the fun moments in this session also. Oh my God, that's really awesome. Yes, kids, number of questions will be asked on those exceptional cases only. There is actually no exceptional case. If we are going to find out the reason for it, then there is no exceptional case. Let me tell you. First of all, let me tell you, this is more stable than that form by 12 kilocalorie per mole. This is more stable by 12 kilocalorie per mole. But see, kids, it's not always like that keto form is going to be more stable. I am going to tell you all those forms where enol form is more stable. So I am going to tell you. So let me write down the statement. Generally keto form is more stable, but in some compounds enol form is being more stable. Enol is more stable due to certain reasons. So are you ready? Are you ready to understand what in some compounds enol form is more stable, and this is going to hold a hell lot of weightage, and the examiner is interested in this only, this part only, and this part is most important for examination. Number of questions will come from this only. Very important, very important, very important for your examination, for the marks. Are you ready? Is everyone ready to understand those examples, those lovely examples, and the reasons behind it? Are you ready, kids? Do let me know. I will let you know. I will let you know. Now see, kids, what I have told you, keto form remains in 99% and enol form remains just in 1%. Now everyone is ready. I can see in the chat section. Case number one. Case number one. See everyone. Case number one. Case number one. When enol gets aromaticity, when enol gets aromaticity, you know, the most stable thing responsible for the stability is being aromaticity. Aromaticity is the character which is going to provide stability to the compound. So when enol gets aromaticity, when enolization gives aromaticity, I can say when enol gets aromaticity, even I can say this thing like when aromaticity is developed when aromaticity is developed in the enolic form, in the enolic form. This statement can also be written like this: when enolic content, when enolic content develops aromatic character, aromatic character. Now, ultimately, what does it mean? It means when there is aromatic character or aromatization, or the enolic form becomes aromatic, then see. Then enolic form becomes 99.99%. Kids, you see, upside down, left side right, outside in, inside out, the whole thing got changed. It has taken U-turn. What I've told you. Otherwise, generally keto was 99%, but when the enol is aromatic, then enol becomes, let me tell you, otherwise you won't be able to understand. Let me explain it in the box. Let me put inside the box and draw one line. Let me draw one line. Now what I'm saying, generally in between keto and enol, who is more stable? In between keto and enol, who is being more stable? That keto form is being more stable than enol. This is 99% and this is just 1%. But when in between keto and enol, the enol is being aromatic. If enol is being aromatic and this is being non-aromatic, then what will happen? It's what I'm telling you. What is going to happen? Everyone do let me know. Then the enol form will become 99.99% U-turn. See, are you able to understand what this table is saying? Now, are you ready to see those examples where this is going to happen? Everyone, are you ready to see those examples? What I have written over here? Do let me know, everyone, what I have written over here. 99.99%. It's too much. So equilibrium has been shifted toward this side. Now see examples. Case 1 examples. Everyone see. Case 1 examples. Examples of case 1. See, if I write down this compound, you see how many acidic alpha hydrogens are there in this compound? Do let me know, everyone. How many acidic alpha hydrogen atoms are there in this compound? You can see this hydrogen is sp2, sp2, carbon, sp2, carbon, sp2, carbon. All these carbons are being sp2. So they are not acidic alpha hydrogen atom. sp2, 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 sp2. But if you focus over here, these hydrogens are being attached to alpha hydrogen, which is being sp3 hybridized. So these two are acidic alpha hydrogen atoms. So this compound is having two acidic alpha hydrogen atoms. So what is how the tautomerism is going to take place? See, I've told you 1, 2, 3. What to do? What to do, kids? Just transfer this hydrogen atom from 1 to third atom. How the tautomerism is going to take place, and the double bond in between 1 and 2. Are you agreed? This I have told you or not? Just transfer hydrogen atom from first to third atom and double bond in between 1 and 2. Now see what you are going to get. Do let me know what you are going to get. The compound was like this. This double bond will remain over there only. This double bond will remain over there only. This oxygen is going to get hydrogen and the double bond will come over here. Now see kids, this compound was non-planar, so non-aromatic, non-planar. Non-planar means non-aromatic, kids, non-aromatic. But once it has become enol, you can see all the carbons are being sp2 hybridized and there is aromaticity. This is being aromatic. It has got the happiness of aromaticity. Now this compound is saying, oh, I got the AIM seats. I have got AIMS Delhi. Now I'm not going to go back. Planar means all carbons are being sp2 hybridized. This is being benzene ring. This is being benzene ring, benzene ring. Now kids, all the carbons are sp2 hybridized. That means this ring is planar. Ring is planar. Ring is planar, kids. Now it is having how many pi electrons? It is having 1, 2, 3, 4, 5, 6. So it is aromatic, following Huckel's rule. It is following Huckel's rule. Why it is following Huckel's rule? Because it is having 4n plus 2 pi electron system, that's 6 pi electrons. So the equilibrium will go toward this side only, that is 99.99% enolic content. Enolic content. Content means when you are going to separate keto from an enol form, enolic content you will get 99. Kids, everyone is able to understand or not? Are you able to understand or not? Now, I'm going to give you one question for homework. Or right now you can do it. See, if I give you compound like this, just see to it, everyone. If I give you compound like this, and do let me know, what do you think, tautomerism will take place or not? How many acidic alpha hydrogen atoms are there in this compound? How many acidic alpha hydrogen atoms are there? Just try to find out, kids, how many acidic alpha hydrogen atoms are there. So the answer is Zupak. Zum zum Zupak. Zupak. How many acidic alpha hydrogen atoms? First 6. Fantastic, kids. Fantastic. Your answer is absolutely correct, that there are 6 acidic alpha hydrogen atoms. So how many times tautomerism will take place? There are 3 carbonyl groups. You can see there are being 3 carbonyl groups. 1, 2, 3. So with respect to each carbonyl group, tautomerization will take place. 3 times tautomerization will take place. Now what is going to happen in tautomerism? You see, if I say 1, 2, 3, the hydrogen atom will shift from 1 to 3. Now what is going to happen? This double bond will come in between 1 and 2. Same here, this hydrogen atom is going to shift from 1 to 3 and this double bond will shift over here. Now here also this hydrogen atom is going to shift on this oxygen and this double bond will shift over here. Now what you are going to get, kids? Do let me know. If you are able to understand, do let me know, everyone. What is going to happen? Now this compound will gain aromaticity by tautomerization, that it is going to become like this. Double bond over here, double bond over here, double bond over here. This OH OH and OH. You can see this has gained aromaticity. Hey, I have become benzene. The time for celebration. It's festival time. Yes, this compound is going to be 99.99%. 99.99%, because this is being aromatic compound. Aromaticity is gained. Now, compound's name is 1, 3, 5. 1, 2, 3, 4, 5. 1, 3, 5 trihydroxybenzene. This compound's general name is very, very important. This compound's general name is fluoroglycinol. 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 Glucinol. This is the general name. This will not come back because that is very, very important. So when you write NEET, how much mark you get? So, oh my God, don't worry, I'm engineer, right? So kids, everyone is able to understand how many times tautomerism has taken place? 3 times. 3 times tautomerism has taken place. Tautomerism. Now kids, should I give you rank deciding question? Everyone, do let me know. Should I give you rank deciding question? See, rank deciding question. Now I'm going to give you rank deciding question. See everyone. Rank deciding question. This is for AIMS Delhi. AIMS Delhi. If you want to go AIMS Delhi, then you have to do this question. You have to have that much of knowledge. See to it. This is the compound. Now do let me know, first of all, what do you think, this compound will show tautomerism or not? And which form will be more stable, its keto form or enol form? That is the question. First of all, do let me know whether this compound is going to show tautomerism or not. And if yes, then which form is going to be more stable, its keto form or enol form? So some are writing no, some are writing yes. So kids, 99% students, 99% students, they will say no. The answer will be no. 99%. But 1% students, they will say yes. Now see kids, why no, why yes? If I say this carbon and this carbon's hydrogen, they are being not acidic. Why? Because this carbon is sp2 hybridized. sp2 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 sp2. So their hydrogens are not acidic. These hydrogens are not acidic. These 4 hydrogens are not acidic. Not acidic hydrogen atoms. Because, or you can say they are vinylic atoms. Vinylic atoms. Vinylic atom. I must have told you, captain of the ship. But if I talk about this carbon, what will you say? This carbon is being sp3 hybridized. All single bonded carbon are being sp3 hybridized, and these hydrogens are definitely going to be sp3. So they are acidic hydrogen atoms. You remember, I've told you in the starting that X double bond Y and single bond Z. X double bond Y, single bond Z, and these atoms are hydrogens. So what is going to happen? this hydrogen will move from 1 to 2 to 3. It will go to third atom, 1 to 3. This hydrogen atom will go from 1 to 3, third carbon, and double bond will shift in between 1 and 2. Then you will get its tautomeric form. See what tautomeric form you are going to get. You will get compound like this. You will get compound like this. Already one hydrogen atom was there, one more hydrogen atom has come, and this double bond has been shifted in between these two. Now kids, you can see these hydrogens have become acidic. No, they are not acidic, they are become non-acidic because all these carbon atoms are sp2 hybridized. But now what we can see, this carbon has become sp3 hybridized, so they are acidic alpha hydrogen atoms. Now once again the tautomerism will take place. How the tautomerism is going to take place? 1, 2, 3. This hydrogen atom will go to third atom and double bond will come in between 1 and 2. So just see to it, everyone, what is going to happen. This compound will look like this. Now the compound will look like this. This bond will remain over here. This bond will remain over here, and this will come over here. And OH, can you see this compound has gained aromaticity? Now this is being aromatic compound, and so it will exist 99.99%. and you can see overall hydrogen atom has moved from where to where. If you compare, this hydrogen atom has moved from 1, 2, 3, 4, 5, from first to fifth atom. First to fifth atom. What type of tautomerism you will say? This is example of, super example of pentad system. An example of pentad tautomerism. Pentad, I've told you in the starting, there is only one example of pentad which is in our syllabus. This is pentad tautomerism. Kids, oh my god, you got it. This is phenol and pentad. Yes, this is being phenol. So phenol is highly stable and this is phenol. Kids, everyone got it? Is everyone able to understand? Do let me know. Omar is saying, sir, please go to the previous slide, the one after alpha hydrogen table, the example you said only 2 alpha hydrogen. Okay, see which example you want to say, Oman? This example, are you talking about this example? So see, 2, 2, 2, 6. With respect to each carbonyl group, 2, 2, 2. So 2 plus 2 plus 2, 6 alpha hydrogen atoms. You're talking about this? Are you talking about this one? Or this one? This one? So they are being sp2 hybridized. This is only being sp3 hybridized. So 2 acidic alpha hydrogen atoms. Rest are being vinylic, they are not acidic alpha hydrogen atoms. Omar, alpha hydrogen examples. So this one, Omar, slide number 7. Slide number 7. So this one, Omar, are you talking about this slide? Do let me know. Omar, hurry up, Omar. Are you talking about this slide? Fast, fast, quick. Ninth. Okay, so this one. Okay, so you will say, sir, why not you are counting this one, these hydrogen atoms? Yes. So with respect to carbonyl group, we are having two acidic alpha hydrogen atom. With respect to double bond, we are also having two more. I think you are wanting to ask this. So two acidic hydrogen atoms with respect to carbonyl group, carbonyl group, and two with respect to double bond. Right? I think this one now. Okay, so let me tell you one question in 2017 has been asked. Whatever the question Omar Adnan is asking, let me tell you, this is really awesome question. Let me tell you, kids. On the basis of this, only one question was asked in 2016 or 15 or 17. I don't remember, but yes. See, this question was asked. They have given this compound. See, and they have asked whether this compound will show tautomerism or not. This compound will show tautomerism or not. Kids, this was a really awesome question. Let me tell you, they have asked this question whether this compound will show tautomerism or not. Do let me know. This compound will show tautomerism or not. So what's your answer, kids? What's your answer? Yes. Oh my God. Everyone's answer is correct. Yes. That time, the students of other coaching, they said no. But my students, they all said yes. Because others were just thinking of hydrogens over here and they said no. But you see, these hydrogens are responsible for tautomerism. Yes, they will eliminate out. There are two acidic alpha hydrogen atoms with respect to double bond. Olefin, that is double bond. So it will show tautomerism. Definitely it will show tautomerism. And this hydrogen will come here and then here. Yes, definitely. Kids, everyone is able to understand, and that's why basic fundamental thing and the knowledge is very, very important. If you're not having in-depth knowledge, you won't be able to do such type of questions. Now let me tell you case number 2. Now everyone is able to understand this much. Now let's move towards case number 2. I hope that everyone is ready for case number 2. See to it. Case number 2. Case number 2 says, the compound, when the compound is like this, this CH2 is known as active methylene group. This CH2 is known as active methylene group. Now, in the examination, how will you find out what is active methylene group and how to trace it? The CH2 flanked by two carbonyl groups is known as active methylene group. Always remember, CH2 flanked by two carbonyl groups CH2 flanked by two carbonyl groups is known as active methylene group. Flanked by means two bodyguards. CH2 is having two bodyguards. And what are R? What are these R? These R can be phenyl, hydrogen or alkyl. These R can be phenyl, hydrogen or alkyl. Do remember, this R can be phenyl, hydrogen or alkyl. Now, when you are having this type of compound, then its enolic range, enolic content will range from 76% to 99%. 76% to 99%. What is the percentage, kids? Once again, let me tell you, 76% to 99% whenever you are having this type of compound. Now, this is to just, I've told you the enolic content. What's the reason? Whether we have to cram it? No, kids. I'm going to tell you the reason for it. Just be ready. Are you full on Josh? Are you with full energy? Do let me know. Everyone. Yeah. Every question will come from here only. Let me tell you, kids, not even a single example is going to come from outside. Whatever the question you are going to get in NEET 2024-25, you will get each and every example from my notes only. Because I'm telling you, I have been teaching for the last 23 plus years, and that much is the experience from where the examiner can give the question. And that's why it is important, kids. Now, let me tell you the reason for it when you are going to get this much of percentage. Now, see, kids, what I've told you, the compound is like this: R, C double bond O, CH2, C double bond O, R. Now, do remember, when both the two are, when both are phenyl, when both are phenyl, then the enolic content will be 99%. 99%. Case number 2, when 1 R is phenyl, when 1 R is being phenyl, then the enolic content is 90% approximately. Third, when both are hydrogens, then the enolic content is 77%. And the last one, when both are alkyl groups, then the enolic content is 76%. Kids, no need to remember the percentage because it's not. Bala is asking, sir, your age. I'm right side of 50. I'm 49 plus. Bala, Bala is asking my age. Bala. My age is 49 plus. Approximately, you can say 50 years old. Now, you are not going to believe it. No one is going to believe it that I'm 50 years old. Yes, I'm 50 years old, kids. Yeah, this is sufficient. More than sufficient, Dinesh. Yeah, little bit. I know Tamil. One randa mule nale anche are ere. One randa monu nale anche are ere ate. Ingeva. Sambarella. Teacher adicha. Friends pidicha. Now, kids, are you able to understand? Now, kids, see to it. Everyone, come back. Come back, kids. So, this percentage is not important. But yes, whenever they are going to ask question that arrange the following in decreasing order of enolic content and whatever the thing, then you should know a little bit. See, this much difference is very, very less. So, most probably it cannot be asked, but yes, they can ask you this 99% and in between this 77 and 76%. So we should have an idea about the percentage. We should have. Thank you, Princia. Thank you. Thank you, Princia. Thank you, Vedha Janani. Thank you, kids. Really, it means a lot that you kids are liking my teaching. I'm very new to YouTube. I was teaching in offline, whatever the number of coachings, you can take the names, whether it is Alan, I was there for 13 years, Vedantu, I was there, Bansal classes, I was there, Akash, I was there, whatever the coaching, renowned coaching's name you are going to take, I was there. Fitji, I was there. Kids, now see. Yeah, in Alan, I was there in Kota and Chandigarh for 13 years, 13 years. Bansal, I was in Kota, right? Now see, everyone come back. Now let me tell you, why is this so? Reason. See, first of all, let me tell you why this is known as active methylene group. RC double bond O and C double bond O R, and this is CH2. Why this CH2 is known as active methylene group? Why this is known as active methylene group? Active methylene group. See, kids, everyone see to it. If this is going to lose its hydrogen, when some NaOH is going to come, and that NaOH is going to abstract its acidic. This is active methylene group, that means acidic alpha hydrogen atoms. Now this is going to lose, it is going to become like this, R C double bond O CH negative C double bond O R. Now see, just see to it. Everyone see to it. Focus over here. This can do resonance over here. And this can do resonance on this side also. This can do resonance on this side also. So it is known as cross conjugation, stabilized by resonance, negative charge. Negative charge is stabilized by resonance. Now, along with resonance, there is also one thing you can see very clearly, that it is putting minus I. So stabilized by inductive effect also, stabilized by resonance as well as stabilized by inductive effect. So this conjugate base is highly stable. You can see this conjugate base is highly stable. Highly stable conjugate base. Now this is the one reason why this hydrogen is being acidic. Reason for this is active methylene group. Now second question arises, SBI, don't say State Bank of India, it is stabilized by inductive effect, SBR, not the State Bank of Rajasthan. It's not the State Bank of Rajasthan, it is stabilized by resonance. Kids, do let me know that you are able to understand. Yes. Now question arises, why the enolic form is being more stable? What's the reason for that? Why enolic form is being more stable? Now let me tell you why enolic forming is being more stable. Just see to it. Suppose if I have taken this compound CH3, C double bond O, CH2, C double bond O, CH3. Experimentally, it is found that this form CH3, C double bond O, CH double bond COH, CH3, this form is 76% and this is just 24%. Now you can see very clearly that enolic content is being more. Now what's the reason? If you see, everyone, this compound is having no resonance in this compound. No resonance. But if you see this compound, this is pi bond, this is pi bond. Can you see the pi bond? This is pi bond and this is lone pair. Up to here there is resonance and that is extended conjugation. If you see, if you try to find out from here to there, the compound is having resonance. This compound is stabilized by extended conjugation. What word I am going to use? This compound is stabilized by extended conjugation. Everyone, can you see? The enolic form is stabilized by enolic form is being stabilized by extended conjugation. This is the main reason. This is the main reason for the stability of this form. This is the main reason. This is main reason. Now, there is also one more reason. You can see this compound is having intramolecular hydrogen bonding. Intramolecular hydrogen bonding, and this is known as chelation. Intramolecular hydrogen bonding is known as chelation. So this was the first reason, and this is the second reason, that enolic form is stabilized by chelation. What is chelation? That is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. It is stabilized by intramolecular hydrogen bonding, kids. So these are the two reasons by which enolic form is being more stable. So see, kids, there is no case as such called as exceptional case. When we use the word exceptional case, that means we are not having that much of knowledge. To explain the things, knowledge is required. and if we are having knowledge, then there is no exceptional case. I hope that everyone is able to get it. Yeah, lone pair is also doing resonance. So I hope that everyone is able to understand why the enolic content is being more. Have you got it, kids? Now see how the question can be asked in the examination. And let me tell you why, if there is benzene, why it is being 99%. Let me tell you, see kids. If I talk about this compound, suppose this is your compound, C double bond O, CH2, C double bond O, now see both the two types, right hand side and left hand side, both the two sides, they are being phenyl. Now when the tautomerism is going to take place, this hydrogen atom will move from 1 to 3 and double bond will come in between this. How it will look like, see everyone. Its enolic form will look like this. Benzene, C double bond O, CH double bond COH, and this is being phenyl. Now see, the resonance is taking place from where to where? This is already having resonance. This is pi bond, this is pi bond, this is being lone pair, and this is being pi bond. That means there is resonance in the whole compound. The whole compound is being resonance stabilized. This is the resonance in the whole compound, and that's why its enolic content is being 99%, because this compound is highly stabilized by resonance. Too much resonance is there. Wow, Bala, really awesome. So this compound is highly stabilized. This tautomeric form is highly stabilized by resonance. So everyone happy? Can you see this is being the keto form, and that is being the enol form. This is being the enol form. This is being more stable. Now see kids, let me tell you some cases which are really awesome cases, super cases. Now let's see kids. If I say one note, let me tell you one note. This is super awesome note that esters do not tautomerize. Do remember, esters do not tautomerize. Now kids, one is this statement. This is true, absolutely true. One more statement I am going to give you, that is also very true. So examiner can ask in any way, but see to it. One ester out of 1 million esters, do tautomerize. Now what does it mean, kids? One ester out of 1 million ester do tautomerize. So what do you say? Esters tautomerize or they do not tautomerize? One ester out of 1 million esters do tautomerize. So what do you say? Esters tautomerizes or esters do not tautomerize? So definitely, if you are going to eat one full plate of rice, or one full pizza, and you took one piece of onion and you have given to friend, hey, you also taste it. You are having one full pizza, big size pizza, double layer cheesy pizza, and you have given one small part of onion to your friend, just taste it. And when you came back to your school, you are saying, hey friend, yeah, we have enjoyed pizza, I have given the party, how was the party? Now what your friend will say, oh, I have eaten pizza or not? So it is just like nothing you have given, nothing you have shared. So you can say Esters do not tautomerize. Now question arises, why Esters do not tautomerize? What's the reason why Esters do not tautomerize? Let me take one ester, CH3, C double bond O, O, C2H5. Just see to it. This compound is having oxygen, and this oxygen's lone pair, you can see this pi bond and this oxygen's lone pair, they are doing resonance. So they are busy in resonance. They are busy in resonance. So this is stabilized by resonance. Now by chance this alpha hydrogen is going to lose this hydrogen. So how it will look like? See, if it is going to lose, if I say it is going to lose, just let us suppose it has lost. Now it will look like this. Now this carbon's negative charge is saying, hey oxygen, do resonance with me, do resonance with me. Oxygen is saying, no, I'm not going to do resonance, I'm not interested. But carbon is saying, why you are not interested? That oxygen's pi bond will say, you don't know, you can't understand that I am busy with the resonance with my oxygen. I'm having resonance. I don't have time for you. I can do resonance either with oxygen or I can do resonance with you. But oxygen and me, they are almost of same energy level. Your energy is different. So I'm not going to do resonance. So this will remain almost localized, almost localized. So this is highly unstable, highly unstable. It will feel highly unstable. So this conjugate base is highly unstable. So this process will not take place. This process can't take place. This process will not take place, kids. Are you able to understand what I am talking about? This process cannot take place, and this is not acidic. This is very, very less acidic or not acidic alpha hydrogen atom. So that's why esters do not tautomerize. Esters do not tautomerize. Kids, you got it? But let me tell you the super note, super awesome note that is really very, very important. See to it. Most important note, most important point. This the examiner will ask. This is really very, very important. See, esters with active methylene group. You know active methylene group. Esters with active methylene group do undergo tautomerization. Do undergo tautomerization. Why? What's the reason? The well-known example is well-known example. I'm going to give you well-known example. Well-known example. So well-known example is CH3, C double bond O, CH2, C double bond O, OC2H5. This is well-known compound. When you come in class 12th, this is known as the compound which is formed by Claisen condensation. But right now, I'm not going to take name Claisen condensation because now you will get worried. What is that? That you will study in class 12. But yes, this compound's name is very, very important. This compound's name is very, very important. Let me tell you how the name you are going to deal with. This is ethyl. This is ethyl. And this one is aceto. This much is aceto. And this much part is acetate. This much is acetate. This much part is being acetate. So its name is, just see, its name is ethyl. This is being general name, and examiner will give you this compound with this name only, ethyl. The yellow part was aceto, and this white part is acetate, ethyl aceto acetate. Now, how to find out this compound is having active methylene group? I have told you one thing, kids. This is carbonyl group. This is carbonyl group. When two carbonyl groups are the bodyguard, then this is known as active methylene group. Got it? Active methylene. Now, it is having resonance. It is being resonance stabilized. But once this hydrogen is going to move, see what is going to happen, kids. What is going to happen? It will look like this. CH3, C double bond O, CH double bond COH, and C2H5. It was having resonance. This is also having resonance. Both of them are having resonance, but this compound is going to get extra benefit of intramolecular hydrogen bonding. Chelation is there, and this is going to get stability due to chelation. But chelation, that is being intramolecular hydrogen bonding, is not that much dominating. So this is found to be just 7%, and rest the keto form is 93%. The enolic form is just 7%. But yes, enolic is this much. That is also better. That at least something is better than nothing. Kids, are you able to understand? Bala is asking, what question Bala is asking? Bala, where I will share these notes on PDF in the Telegram channel. This notes PDF I'm going to share in your Telegram group, right? Have you joined the Telegram group? Are you there in the Telegram? Have you joined the Telegram group, Bala? So there I am going to share the PDF. But right now, let me tell you, kids. Now these things I have told you, 90% of the work is completed. Whatever I have told you, let me give you number of questions on the basis of this, and then I will let you know a little bit more about this tautomerism. Are you ready? Everyone ready? Or you need break of 15 minutes? Everyone is ready, or you need break of 15 minutes? Kids, do let me know. Everyone do let me know. Are you ready, or you wanna have break of 15 minutes? It will take near about 40 to 45 minutes more. Ready? Everyone is ready. Now see. Question and answers. Question number one. Question number one, kids. Arrange the following This is a really awesome question. Arrange the following in decreasing order of enolic content. Sit with your pen and copy. Just see the question. Arrange the following in decreasing order of enolic content. Sit with your pen and copy and try to get the marks. What percentage, how many questions are you getting on the positive side? See, if I say A is CH3, C double bond O CH3, B is being C is being and D is being, you can see your notes, whatever the notes I have given you. So these are the four options, and let me give you the options: A, B, C, D. These are four compounds. Let me form the options. First is A, B, C, D. Now the second one is these are the four options. Kids, do let me know what's the answer. Just see to it. You can see your notes, whatever you want to see. You can take help from the notes, but I want correct answer. Chiti Kana. What's the name? Chiti? Yes, kids. What's the answer? Subhasri is saying A. Everyone try to find out the answer. Apply your brain, full brain. Kids, just see to it. Vedha Janani, always, I think, applying brain. And I don't know whether answer of Vedha Janani is right or wrong, but yes, she always apply brain with proper homework, hard work. Now see kids, let me tell you, you see, its enolic form will be what? Its enolic form will be aromatic. Its enolic form is going to be phenol, and that is being aromatic. See, its enolic form will be like this. Can you see? This is phenol. So it is going to be 99.99%. So this has to be on the first position. So this can't be the answer. This can't be the answer. It has to start from B. And this is being normal ester. You can see this is being normal ester. This is being normal ester. So it will not tautomerize, Kids, are you able to find out? Will not tautomerize. So it should be at the last, starting from B, ending to D. This is the only option. This is the way how to do the question. Kids, Shiv Kumar, Priyanka, everyone's answer is correct. Those who got the correct answer, show me the thumbs up. And if your answer is wrong, show me thumbs down. Kids, thumbs up, thumbs down. I want to see your answer. Everyone do let me know. Thumbs up, thumbs down. Yes, kids. Once again, arrange the following compounds in decreasing order of enolization, or that is enolic content. Both mean same. Enolization, right? Now kids, try to give the correct answer. I'm waiting. I'll be waiting for your correct answer, kids. The compound A is being CH3, CH2, CH double bond O. The compound B is C6H5, CH double bond O. The compound C is being C6H5, CO, CH2, CO, C6H5. The compound D is being CH3, C double bond O, CH2, C double bond O, O, C2H5. Whatever I taught you, I'm asking questions from there only, kids. Now let me give you options. What's your answer? Take your time and try to give the correct answer, kids. Everyone, take your time and try to give the correct answer. I want answer, kids. Wow. Chitikana, Priyanka. Yes. Congratulations. Kudos. Great performance. Stupendous performance, kids. Bala, your answer is wrong. It's not D. It's C. C, kids. Why? Everyone see to it. This is not having any alpha hydrogen. No alpha hydrogen atom. So no tautomerization. This will be at the last. This will lie at the last. So in which option this is lying at the last? B, B. So this can't be the answer and this can't be the answer. This has to be at the last. Now this compound, C compound, if you see this C compound is like this. Phenyl, C double bond O, CH2, C double bond O, and phenyl. This is compound with active methylene group. Its enolization is 99% enolic content. This I have told you or not. So this has to be at the first position. So its enolic content is 99%. It's being just 7%, and it was just 1%, and it is 0%. So it has to start from C. Starting from C and ending to B. This is only the answer. Get C is the correct answer. Everyone got it? Everyone got it? Are you enjoying the questions or not? Such type of questions has been asked in various examinations in If I talk about IIT, if I talk about AIMS, when AIMS was taking separate examination, this type of questions has been asked. Now it's the turn of NEET NTA kids. Now this time, Chitti Kanna, you have given the answer within time and very fast. Now kids, see who is going to give next answer. The question is, see everyone, A is formaldehyde. A is being formaldehyde. B is this is B. C is D is this is D. Okay. Now let's see whether you are able to do it or not. A, B, C, D option. Let me give you. Yes, I'm waiting for your answer, kids. Oh, Subhashri, fantastic. Princia, wow. Yay, my God. Super awesome. Really, I'm feeling accomplished. Your stupendous, marvelous performance, Subhashri, Princia, Prajnajanani, Aarti, everyone. Now, really, you are rocking. Now, see, kids. Now I'm really feeling fantastic. This is going to give 99.99% enolization. This is going to 1% enolization. This is going to give 0%, will not tautomerize, and this is going to form 7%. If you don't know the percentage, no problem. It has to start from B. This is not starting from B. This is not starting from B. This is not. So only one answer is there. This is starting from B. Even if you know that this is starting from B, then also you could have given the correct answer. Kids, are you able to understand what I am saying? Now, even with the help of one option, you could have given the correct answer. Now, are you waiting for another question? That time, Vedha Janani, then Chitti has given the answer. This time, Subhashri and Princia has given the answer. Now, kids, Princia is asking, sir, please explain the last question. Which one? Which one? Kids, do let me know. This one. Princia, you are asking for this one. Which question, Princia? Bacha? Yeah, okay. Now see, Princia, this is having active methylene group. You see, this is being phenyl. This is being phenyl when both the R are phenyl. When both the R are phenyl, and this is being active methylene. Active methylene. So do remember, I have told you this is going to form 99%, means has to start from C. And you see, this is benzaldehyde. B is being benzaldehyde. Benzaldehyde is not having any alpha hydrogen atom. I've told you in the starting, no alpha hydrogen atom. So can't show tautomerism. can't show tautomerism, and it is normal aldehyde, so 1% only. And this is ester with active methylene group, ester with active methylene group. Got it? Princia, is it correct? Got it? Okay, got it. Now see, another question. Let's see who is going to give the correct answer. A is CH3, CO, CH2, CHO. Just try to understand what the compound is written. Otherwise, you won't. B is C is D is I'm going to give you options. So let's see who is going to give the correct answer. Karthik Kumar Singh D. Subhasri is saying A. Bala is going for A. Vidhajanani is going for A. Yes! A is the correct answer. Oh my God. Really feeling good. How much happy your teacher is right now. Teacher cannot explain in words. Your HSP Baba is how much happy. I can't express my happiness, kids. Really, you have proved really, really. Now, see, you are able to understand this compound. This compound is like this: R, C double bond O, CH2, C double bond O, R. So its range was 77% to 99%, but this is R and this is, so you can say 76 to 77%. It's enolic content. And this is pentad system. If you remember, this is being pentad system, and its enolic form being aromatic. Enolic form is aromatic. So once the aromaticity is there, 99.99%, and this is simple one, so 1%, and this is no alpha hydrogen, so it will not show no alpha hydrogen. So it has to start from B, then A. B, A, only one is starting with B, A. So this is being the correct answer, kids. Oh my God. Really, really, I can't tell you that how much happy I am right now. Now see, kids. Another question. Option A is option B is option C is Option D is now let me give you the options. So let's see who is going to give the correct answer. Oh my God, Subhasri. Subhasri, now to really, I will say thank you, Subhasri. You are really what to say, everyone. Not only Subhasri, but yeah, first answer I'm going to get from Subhasri, but everyone is given me these. Really thanked Almighty God from the internal core of to Almighty God. Kids, really, really, you are awesome. Really, kids, how much accomplishment I'm getting, how much happy am I can't tell you. Let me drink a sip of water. My godness, really, really, kids. In the starting, I was not happy when the one question, two questions I have given. But as the time is moving, kids, really, you are proving. Oh my God. I can't express that how much happy am I. Now, kids, really great performance by all these students. Now, question is, which compound will not show tautomerism? Will not show tautomerism. Option A is CH3, CH2, CH3. Option B is H, C double bond OH. C is D is what's your answer? D. Priyanka. Yes. Bala Vidhajanani. Oh my God. So fast. Yes. Now though you have become super duper students. Really. Now question is, which compound will show tautomerism? Options are CH3, COO, CH3, B option, C option. D option. So what's your answer? Pitha Janani, fast, super fast, Shiv Kumar, everyone, so super fast, kids. Answer is C. Absolutely correct. Now, kids, now I'm not going to give you questions. Now, let me tell you that concept. Now, only 10 to 15 minutes are required, and this session will get over. So, you have shown that great performance, kids. I can't tell you. I can't tell you. Now, see, kids, some other types of tautomerism. Some other type of tautomerism. See to it, everyone. If I write down urea, urea, urea is like NH2, CO, NH2. Now, what do you think? Will it show tautomerism? Answer is yes. X double bond Y Z acidic hydrogen atom is there. And this question has been already asked. 1, 2, 3. Hydrogen atom will come from 1 to 3 and this double bond will shift in between 1 and 2. Now it will look like NH2 COH double bond NH. This is being isourea. Isourea. That is being urea. This is being isourea and they are tautomer of each other. These are being tautomer of each other, kids. So urea and isourea are tautomer. Now see, kids, another example. If I write CH3 CO NH2, this is being amide. You can see this is being amide. Will it show tautomerism? Answer is yes. Now, kids, this is also acidic hydrogen and this is also acidic hydrogen. Both are being acidic hydrogens. So, which will go? That which will go? Now, see, kids. Yeah, I will revise. Don't worry. I will give you questions. Now, this nitrogen's electronegativity is 3 and this carbon's electronegativity is just 2.5. There are 3 plus 2, 5 alpha acidic hydrogen atoms. So which will go? Kids, this is more acidic. So it will go. This is being more acidic. Why it is being more acidic? Because it is attached with more electronegative atom. So it will go. And how the tautomer I will draw? 1, 2, 3. Hydrogen atom will go from 1 to 3 and double bond will come in between 1 and 2. This will look like this. CH3 COH double bond NH, that is known as amido, and this is known as imido form. Imido, they are also being tautomers. Amide is also known as amide is known as amido and imido tautomerism. These are special type of tautomerism. Now see, if I write down compound like this, CH3, CH2, NO2, X double bond Y, single bond Z, acidic hydrogen. This is being acidic hydrogen. 2 acidic alpha hydrogen atoms. Will it show tautomerism? Yes, it will show tautomerism. Now 1, 2, 3. Hydrogen atom will go from 1 to 3 and double bond will shift in between 1 and 2. This is known as nitroform. Nitroform. And once the tautomerism is going to take place, this compound will look like CH3, CH double bond N, OH. This is known as Se form, Se. So this is nitro Se tautomerism. This is known as nitro Se tautomerism. Nitro Se tautomerism. Gets everyone is able to understand. So these are some type of tautomerism other than that tautomerism. Everyone is able to understand. Now, let me tell you the most important thing that is only for rank deciding question, right? Let me tell you Bradts rule. If you know Bradts rule, the question can come on Bradts rule. Kids, that is really awesome. And that is the basic part and most important, Bradts rule. Bradts rule. Bradts. Bread and tomato. Bradts rule. What this rule says, Bradts rule, what this rule says, see kids. According to this rule, or according to Bradts rule, bridge had carbon. Bridge had carbon in bridge bicyclo compounds can't be sp2 hybridized. Can't be sp2 hybridized. Now, how to understand this Bradts rule in simple language? How to understand this Bradts rule in simple language? In simple language, if I say, I will write that bridge had carbon can't be, bridge had carbon can't be can't be double bonded, can't be double bonded or positively charged. Now, is there anything to do this Bradts rule with tautomerism? Yes, this Bradts rule is very, very important to understand tautomerism. Now, see, let me tell you. If I say that I am being provided with this compound, you can see this is bicyclo compound, and Bradts rule says that it cannot have plus charge on it. This plus charge cannot possibly, means this compound does not exist. Or if I say that I have been provided with this bicyclo compound, and if there is double bond attached with this bridge head carbon, this is being bridge head carbon, this is being bridge head carbon, where two cycles are meeting. What is bridge head carbon? Let me tell you. Bridge head carbon, what is bridge head carbon? First, let me tell you, these two compounds does not exist. These compounds doesn't exist. These compounds do not exist. These compounds do not exist. Now, what is bridge head carbon? Where two cycles, means carbon common to both the cycles. I say what is bridgehead carbon means common carbon in between two rings. Bridgehead carbon means common carbon in between two rings. Are you able to understand, kids? What is bridgehead carbon? Common carbon in between two rings. So these two compounds does not exist. Why they don't exist? If you want to understand, then I will tell you why they don't exist. See, this is sp2 and sp2 wants to be like this, planar, trigonal planar. It should be like this, 120-degree bond angle should be there, and you see there is no 120-degree. This is pyramidal, so can't be pyramidal. It should be trigonal planar. It is supposed to be trigonal planar, but it's not trigonal planar, and this is also sp2. So you can say bridgehead carbon in bridge bicyclo can't be sp2 hybridized. Now, how it is related with tautomerism? See, kids, how it is going to get related with tautomerism. Now, see, question, once this question was asked in AIMS and IIT, number of times in IIT this question has been asked. Which compound will show tautomerism? Will show tautomerism. Which compound will show tautomerism? Now, the options are not two options, just I have given two options so that you can understand it. Right now I have given just two options so that you can understand it. B. Very good, Priyanka. Wow, Priyanka, Bala. Kids, everyone is intelligent. What I can see, Subhasri, Vidhajanani, Bala, Priyanka, you kids are limited kids. It's not like huge crowd of students. I'm very happy that I have got only few students, but these few students are going to produce rank. So it's better to have selected students. So this channel is not meant for crowd. This channel is, yeah, deserving for deserving candidates. That's really awesome. Now see, kids, over here in this compound there is no alpha hydrogen, but here is alpha hydrogen, and if this is going to move, it will form tautomeric form like this. And what do you think? Is this tautomer possible? Is this tautomer possible? No, because the bridgehead carbon has become sp2 hybridized, and this can't be possible. This does not exist, so can't show tautomerization. Can't tautomerize. This compound can't tautomerize. Now, this compounds, this hydrogen can't go, this hydrogen can't go, can't participate, can't move. But it is also having these hydrogens. These hydrogens will move. Mobile hydrogens, these are mobile hydrogens, they will move, they will participate. So it will form its tautomer like this. OH. This hydrogen will go, double bond will come over here. This is being enolic form and it will tautomerize. Kids, you got it? This is the Bradts rule. Definitely, this is being Bradts rule. I hope everyone must have got it and everyone is able to understand. Kids, do let me know that yes, sir, we got it. So Bradts rule also you got it. So one kid at that time asked, sir, please deal with the revision of also tautomerism. So I'm going to give you one question that is going to revise each and everything whatever we have studied right now. See, last one question and see to it, kids. Question is, how many compounds will tautomerize? Will tautomerize? pH means phenyl. pH means phenyl, right? Yes. Let's see what's your answer. Some are going for B, some are going for C. So there is tie. Kids, whatever I taught you, just see to it once, then you can answer it. Once see to it, kids, everyone. So I can see majority of students are correct. This will show Diade system. This will show. This will show. This will show. This will not show. This will show. This will not show. It is benzaldehyde. It is benzaldehyde. This will show. This will show. This is normal ester will not show. This will show ester with active methylene group. This is active. This will show. Now, how many compounds will show? 1, 2, 3, 4, 5, 6, 7, 8, 9. C is the correct answer. Princia, Subhashri, Vidhajanani, everyone, kids, Aarti, and number of other students. Those who have got it absolutely correct, you can show me the thumbs up, otherwise thumbs down. And kids, do let me know that how much you enjoyed it. I hope that yes, the real knowledge, the tautomerism, even you will not get these many examples in any book. No book is going to give you these many examples, and in your examination, whatever the question is going to come, the question will come from here only. Whatever the options, whatever the questions we have gone through, and because you have shown really wonderful performance, marvelous performance, stupendous performance. So now you can do any question of tautomerism. Whatever the question is going to come in your examination, definitely you are going to do it, because now tautomerism questions are easy kill questions for all of you kids. Bye to all of you. Have you seen anyone is going to take tautomerism lecture for 3 hours? It is just 2:45. So have you seen anywhere on YT channel? Have you seen any lecture on YT channel? 3 hours tautomerism. Kids, number of teachers, they are going to complete full organic chemistry in 1 hour. They are talking like this. Let's come. Everyone, come on. We are going to complete the whole organic chemistry in 1 hour. See kids, it is requiring 3 hours just to complete tautomerism, because we have to understand, we have to go for in-depth knowledge of any topic. Once if you're getting command over any topic, then that topic is going to be easy kill questions you can do easily. So bye to all of you. Anything else, if you need from my side, from our team side, this is your Conquer batch, and Conquer itself means we have to win, and we are going to win the race, because our process is really awesome. Never worry, never get worried for the result when your process is going with that wonderful, wonderful and fundamentals, wonderful, then really you're going to rock in your examinations. So bye to each and everyone, and anything if you require from my side, any other topics, if you're feeling any doubt, because I think IUPAC we have not done on the YouTube, right? And conformational analysis, conformational isomerism. From the isomerism, only conformational isomerism has been left. IUPSC, I have to tell you, and one lecture of optical isomerism, because anomers, epimers, and allenes and the compounds which do not have chiral carbon but then also they are being optically active. One lecture for optical isomerism I have to take in the coming week, and one lecture for IUPSC I am going to take. All name reactions that I will take later on. Once I tell you, once if I am gone through all the fundamental things, then I will tell you all name reactions lecture, all reagents based lecture. Definitely I will let you know. So kids, I hope that all of you are going to do revision of this lecture, and one question I am giving you, you have to tell me in the comment section. Will you? Just one question for your homework, and you have to tell me in comment section. This is your homework question, kids. Homework question. The question is, number of acidic alpha hydrogen atoms. Number of acidic alpha hydrogen atoms. This you have to tell me in the comment section. Will you please comment your answer? Your HSP Baba will be waiting, and I will share it. I will share the PDF in Telegram group. Okay, kids. Agreed? Promise. Do promise that you will answer this question, kids. And kids, those who have not joined the Telegram group, those who haven't joined the Telegram group, here is the link. Here is the link. And everyone, write down in the chat, I want to see that yes, it's a promise. It's a gentle student promise that you will comment in the comment section. What's your answer? Everyone, wow, great. Princia is there. Aspiring Medico is there. Yeah, that's really awesome that everyone is responding to every action. There is no, not right now. Princia, not right now. I will give you my comment and respond to your comment as the answer, whether your answer is right or wrong. Right now, if you're telling your answer, then definitely it will be out. Let me see how many of you are doing proper homework. So bye to all of you. We'll meet you next turn with awesome session. All the best to all of you kids. Bye. Have a great time.